So this is an exciting set of slides that I have for us starting today. Be another couple lectures to get through it. This is about objects and classes. Very, very important topics for modern day computer scientists to know. Object-oriented programming, OOP for short, is a very, very popular programming paradigm, and maybe you've heard about it. It is all the rage these days still, so it's important to learn about it. Alright, so before we get there, before we get to classes and objects, let me talk to you about a struct. A struct is like a baby version of a class. It'll be like a stepping stone for us, but it's very important to understand. So struct is actually a keyword in C++, so just struct by itself, we're going to be saying that today. And it's short for data structure. Data structure. It's a way to put a bunch of different things together in one big nice package. That's what a struct is all about, okay? What a struct allows us to do is make our own types. So you know how we have int, double, whatever, vector? Let's make our own type called blah or something. We can do that now. Struct gives us that ability. So for example, maybe you're writing a video game or something like that, and you need to keep track of the enemies on the screen. And each enemy has like a center point. That is like a 2D coordinate, right? And so maybe you have a point type. You can make your own point type called P that keeps track of where the enemy is. It can move around. It holds its X and Y coordinate inside of itself, all at once, which is pretty cool. So yeah, a struct, it's a data type that you make yourself. You can give it any name, just can't call it int or something that already exists. So a struct, we're going to make our own in just a second. You get to pick what lives inside of that struct. It's made up of smaller things, right? And you get to pick the names of all those inner things that we call member variables. So that'll make sense in a second. But yeah, struct is short for data structure, which means that word just means, that phrase means it's just some method of organizing, structuring a bunch of data, a bunch of potentially different kinds of data, okay? And every element inside the data structure has its own little name. So maybe, I don't know, I have some type called blah, and I make a variable called s of type blah. There may be 4 different things that live inside of that type. Maybe x is an int, y is a double, z is a bool, p is a char. You have as many things inside of your type as you would like, and it holds space for all of those whenever you make one variable. It's like a box with boxes inside now. So that's my s, maybe s. The type is defined with these different inner things that all have names. Those are called member variables. All right? That'll make a lot more sense in an example, I promise. Yeah, all the data that you store inside of a struct is just in one very nice large package that is named. Okay? You get all of it at once. So you say blah s, you just made space for these 4 inner things. Okay? So in that sense, it's very similar to like a vector or an array where you can hold multiple things with one name. But instead of indices, you have like names for the stuff inside. Not like index 0, but like x. S is x, s is y, stuff like that. Okay? And you'd have multiple different types stored inside. Okay? So names are new, multiple types are new. Does that make any sense at all? So I have a concrete example on the next slide, but did any of that not make enough sense? I think the example will definitely help. Let me consult my notes really quick just to make sure this is where I want us to be. Yeah, good enough for now. Alright, so here's a concrete example. Let's make a point struct, okay? So here's what we'd like to do. We can make a 2-dimensional point type, okay? It will store, like it'll make this type P, or the type is called point. I can make a variable of that type called P, and it will store X and Y coordinates. It will hold on to both at the same time. Isn't that nice? So just in one variable, I have a concept of an inner X and an inner Y. You can initialize it using array style syntax. That totally works. But a point by itself, this type that we're going to make, will represent a 2D point. So it has an x-coordinate and has a y-coordinate. This particular point P will represent the coordinate 2, 3. Maybe that's where the monster is in your video game. All right? So a struct is just a type that we can package a bunch of stuff together. Let's make a struct that packages together the idea of coordinates, the two x and y coordinates. Okay? When we make a struct, we make this type, and then we can make as many variables of that type as we would like. So here is how you define the point type to C++. You say this. You say struct point. And so this is the name of the type I am creating. Struct point. And then you give parentheses, kind of like a function. And then for weird reasons, there's a semicolon after this closing brace. Talk to me after class or during office hours if you'd like to know the real reason why that's there. But you got to remember this closing semicolon. And every point should have two things inside of it. It should have an x-coordinate and a y-coordinate. So I will just declare both of those doubles. Double x, double y. This is what it means to be a point. It has an x inside of it and a y inside of it. Let's just declare those. Okay? And so that gives me this type, and now I can use it like this. I can make a point called P, have it hold 2, 3, with the x-coordinate being 2 and the y-coordinate being 3, because that's the order in which I define these, right? X first, then y. Isn't that neat? Any questions about that? I can make a type with multiple things inside. So let's get there. Let me just confirm that I can get started with some code right now. Yeah, that seems fine. Works for me. So let me start this on a nice piece of code. So let's call this Structs.cpp. I assume that's a good name. So the most important thing is the definition of the point. Struct. So struct point, this creates a brand new type. It has space for a double x and a double y. Okay, so every point will have its own x and y coordinate. And now I can make as many points as I want. I can make point P equals whatever I had here, 2, 3. I could make point P2 a completely different point that holds, I don't know, 2.5, 3.5. Who knows? So here's me making a bunch of points, and they all hold on to x values and y values with names. Okay? So that is the start of it. Are we good up to here? So I made a new type called point. I can use it now. I can make variables of that type. I haven't shown you how to get the x out or the y out yet, but you can initialize it like an array. That sets the x and y. So this will make this is supposed to represent the coordinate 2, 3. Okay? All right. If we're good with that, let's keep on trucking. So, yeah, let's figure this out. There is a bunch of terminology that comes along with all this fancy stuff. So let's go through those bold words. So the idea is struct versus object. First of all, that's important to understand. Then we'll talk about fields and members. So the struct, we know that already. That's the name of the type. That was point. This is the point struct right here. It's the declaration of the type. It's like, here's the type point. Here's what lives inside of every point. They all get an x. They all get a y. Okay? That's the struct. It's the name of the type. An object is a value of a struct's type. So I was lying when I called this the p variable, the p2 point variable. I guess you could think of it that way, but really the technical term, the fancy term, is called an object now. This is the p object. This is the p2 object. Because we're trying to model something in real life, I guess. It's like physical. We think of it that way. Okay? So when we say point p semicolon, we create a point object as a local variable. And since we didn't give any values, if you do it exactly like this, your x and y are just random, just like they would be for any other variable that you didn't initialize. Okay? But you have two things inside of you now that you have forgotten to initialize at this point. So that's important. Yeah, the x and the y pieces that live inside each point that you can set are called either fields or member variables. or just members for short for that one. So fields or member variables. All right, so you can say that P has two double fields called x and y, or you can say P has two member variables that are doubles called x and y. Same word. Those are synonyms. All right? So I can totally make another point that is uninitialized. I'll have to show you how to initialize it. All right, now it's question mark, comma, question mark. We better initialize this before we use it, right? So let me show you that. This is the lovely dot operator, which you already know. You've already used this for strings, right? For vectors, for all these things. These are secretly classes. We'll get into that. But here is the dot operator. Every object, of course, has its own field. So I make a point P, it has its own x and y. I make a point Q, it has its own x and y. They're separate x's and separate y's. It's part of P, part of Q. P has an x and Q has a completely separate x. That's important to keep in mind, okay? To access just the x, just the y, you use the dot. You say your object's name, dot, the name of the field you would like to access. Okay, you can use that to either set or get. So here, you just ask for p dot y, print it out, or you could set it like this, make it on the left side of an assignment. P dot x equals 42. And so I want you to read that dot as an apostrophe s. It's like, this is P's thing. P's x, please. Please set P's x to 42. Please print P's y. That's a good way of thinking about it, I think. And so when you run this line, it's going to go in here and set the x to be actually 42. Okay? This line, p dot x equals 42. P's x, please become 42 now. Okay? And so you can always initialize your struct, your object, like this separately. Be like, Q's x, let's make that 4.5. Q's y, let's make that 7.89. Okay, that's totally fine. Or you could use this array style syntax, where the things that you give in order are the things from the struct. So the x is first, then the y. It'll get set in that way. Okay? You can use that array-like syntax as well if you would like to. Does that make enough sense? The dot operator. You've been using this on strings, on vectors. Those are like functions that belong to the vectors, functions that belong to the strings. These are like values, little variables that live inside of a bigger variable. Objects. All right, so now I can access my stuff. I can actually print out these points that I've made and taken so much care to build, right? So cout, let's print it all pretty with some parentheses. And I'll wrap the x and y coordinates around all this. So I want to output p.x and then comma space p.y. Yeah, with some parentheses around them because that's fun. And then a new line. I'll do the same for q. So I should see 2, 3, 4.5, 7.89. Beautiful. This is all thanks to this declaration up here of this struct. I've made a brand new type for me to use now and package together things that should live together. Any questions about that? Because just imagine the alternative. Like, structs are so nice, objects are so nice, because if I didn't have these, I'd have to do something silly like this. I could either make, like, because these are both doubles, I could technically make an array of doubles and just make the 0th index the x coordinate, the 1st index the y coordinate, or I'd have to do something silly like this. Double px, py. I'd have to make two separate variables for those coordinates, each for the same point. But no, they should live together. They should live together in one object that itself holds x's and y's. That's the beauty of structs. Okay? So let's make sure that was everything that I wanted to show you there. Yes, yes it was. Okay. Are we good to keep going? Okay. So that was the dot. Think of it as apostrophe s. You can do some pretty fancy things with objects, with structs, okay? one thing that you can do with structs is use them as a way to return multiple values from a function. That's interesting to think about, because when you have a function, right, int main, it can only return one thing of one type. But if that type was a struct, you could have multiple things inside of it. Woohoo! Isn't that nice? So yeah, you have options when you want to return multiple things from a function. Option 1 is just use a bunch of reference parameters and just don't return anything. Just make it a void function. But by using references, you can touch all of those parameters. That's one way to return multiple things. Or you just return a struct with a bunch of fields, one for each thing that you need to give back. That would work. Return an object. Okay, so I guess I'll show you both ways. I think that would work. Let's make an add function for points. This might be useful in a graphics library or something. Let's pretend that this is what it means to add points together. So like 2, 3, that coordinate plus 4, 5. Let's make that give back. Let's add those together and make 6, 8. Because if you add points together, you add their x's to make 6, and then add their y's to make 8. And so that's what we'll do there. So let's pretend that's what it means to add points. That's a pretty natural way to add them. So let's make an add function on points that gives back a new point that is their sum. That is the added point. Okay, so let's do that. I'll call it add. It's going to take 2 points, right? Point A and point B. I'll take them by value, because why not? They'll get copied, but that's okay. And we need to return, right, a new point that is the sum of their x's and the sum of their y's. Brand new point to give back. Isn't that interesting? So let's add a bunch of points together. So, I don't know, I have to give back a point. I'll call it result. And I'll eventually return it. But what is the x of result? Results x is, well, it's the sum of A's x and B's x. Yeah, same for y. Results y is A's y plus B's y. And so that'll make the 6, 8, and I want to give that back. So I'll return it. And by returning a point, I've just returned 2 things back secretly, 2 doubles. Pretty logical, right? So I don't know. Point P plus Q is, well, let's add together. Let's call our function P and Q. Those will become A and B, and it'll give me back, I don't know, 6.5 and 10.89, maybe, if I'm doing math right. And then we can print that out. Let's see if it worked. Let's see if it gave back the right thing. Cool. Look at it. So yeah, that's a function on points. Add. We can call it with points that we have, with objects. Any questions about that? It's one way to return multiple things from a function. Technically, I'm returning 2 doubles at once. A box of boxes. So another thing that we could do is make a negate point function. Let me do that the other way. Let's use reference parameters for that. So let's make a negate point function that takes a point as a reference and negates it in place. So here's my P. It's got what? 2.5 or 2 and 3, let's say. It's got an X inside of it and a Y inside of it, 2 and 3. If I call negate point, here's what I want to do. It'll be a void function, but it takes P by reference, and so it'll modify it. If I just say this line by itself, it'll go into X, P's X, and change it to -2. It'll go into P's Y and change it to -3. Okay, that's what I would like to do. So I'll take it by reference, so that I'm allowed to change that variable, just like anything else that I would take by reference. So let's go and do that one. So I'd like to say negate point P. And then I'll print out P again, and it should be -2, -3. Okay? That is the goal. So it's going to be negate point, and it's going to take a point by reference. All right, I'll call it A, I guess. So it'll be somebody else's variable, and I'm touching it. And I'm just going to call it on a line by itself, so it will be a void function, but it's really going to return something by changing a value. Okay? That's how I like to think of it. So A, whatever it is, make its X now the negation of what it used to be. Same for Y. Take its old Y, negate it, put that in for the Y now. That should flip the signs of whatever object you passed in for its X and Y coordinates. And so if I call it here, oops, didn't need this one. Now P's X should have been negated. P's Y should have been negated because this touched it. This A was a reference to X. Or A was a reference to P that I passed along. Okay, so that's negate point. There I am calling it on P. Here's the definition. Then I'm printing out the new P. So I get -2, -3, so I touched that memory. Okay? Any questions about that? Any good still? So just in case this was a little weird, maybe the combination of references and structs was a little too much, let me draw what's happening when I call negate point with P. Okay? So let me draw a stack diagram. So here's main. I made many things in main, right? I made P, I made Q, so many things. Here's main. It has many local variables, right? I made P, P2, Q, P plus Q. P is the one I really care about, so I'll draw that one out in full. P held X and Y, 2 and 3. And then I had, I don't know, Q, P2, held X and Y, P plus Q. Those are all local variables, still they exist, but I want to focus on P, so I drew that one out in full. And then I called negate point on P. So I'm calling the negate point function, and let me draw everything that negate point owns in green. So that means I add onto the stack the fact that I'm running inside of negate point. And then I have to talk about all of its local variables / parameters. Because what is a parameter but just a fancy kind of local variable? So P is getting passed along, and it will be the A inside of negate point. The point reference A is getting set to the P that I passed along. And so negate point has only one thing that it cares about. It's called A. It makes no local variables in its body. This is its parameter. It's its own variable. Okay? So negate point has an A, and there's a reason I needed to use another color because A is getting set to mains P, right? A is getting set to mains P. That's how I'm passing it along. And because it's a reference, A is just another name for the P down there in main. Okay? This is supposed to be Q. You see what's happening there? So then, when I talk about A and change its X and change its Y, then I'm secretly modifying P. It's just another name for that thing. -2, -3. And so that's why it's modifying it and actually replacing those values. Okay? And that's why when negate point returns, it's done with the stack, the A goes away, but the P, of course, lives on. It's part of main. And so then P is changed. Let me print it out. Does that make slightly more sense, maybe? Any questions about this example? Okay. What do I want to do? If we're good, I have a question for you now. I would like you to write a definition of a line segment struct that represents the start and end points of a line. Because here's the idea, right? How do I want to say this? Yeah. What is a line but something that looks like this, right? It's got, let's say it's a 2D line. You can completely specify a line by saying where it begins and where it ends, right? That fully specifies this exact line. If you give the coordinates of its start and its end, right? So I'd like you to make a line segment struct. I can initialize like this, line segment ls or something, and then I can fill it in a way that I can hold the start, I can hold the end, and represent a line segment. Does that make sense to us? I'd like you to make this struct. Call it line segment. What would you put inside of it? How would you hold the start and end points of a line? All right. So here's the struct definition for point. Use that as your guide. So you're going to make your own struct definition. So please get it. You don't have to write this down on the Google form or anything, but the Google sheet. But I'd like you to make me a struct line segment, curly brace, semicolon. How would you represent a line segment? How would you have it hold the start and end points of some line? Okay? That's what I want you to think about. Take a couple minutes to convince your neighbors that your way is correct. All right, that was my timer. What did we come up with? I guess I don't need to fill this out with anything. But it's got to be struct line segment, right? Open braces, closing braces. What did you guys put inside? Anybody brave enough to share? How'd you hold the start and the end points of the line? Sure, that'd work. So you got the coordinates of the start and the coordinates of the end. Does anybody else do things differently? Is that, I heard some other groups saying similar things. Is that what we all agreed on? That would totally work. You could store these separately, just like this, x1, y1, x2, y2. But I think there's a better way. What is the start but a point? What is the end but a point? Why not do it like this? Do you see where I'm going with that? Point start. You can go deeper. Point end. You can put types that you've already made inside of new types. Totally fine. That's a bit cleaner, I think. So now if your ls looks like this. It has a start and an end, exactly what you wanted to hold, and those worried about representing each point, right? Those then hold x's and y's. So it's a box with boxes that themselves have boxes. And then if you wanted like the y coordinate of the start, you would say something like ls dot start dot y. It's another struct inside of it. Dot start dot y. Does that make sense? Any questions about that? That, I think, is the cleanest way to do this. Because if you already have a point, like we have up here, use it. Point start. Point end. Okay? I'd rather you do it that way. But this is equally valid. This will still work. Maybe for some implementations this would be the better option. But I think I like this one better personally. It's a bit cleaner. So yeah, use whichever one you want. So you have options. Any questions about that? Yeah.
Can you show us using?
Sure. Put all these in a weird way. Call this line segment 2 or something. You could do it in this way. You'd be like ls.start.x equals 2, ls.start.y equals 3, and you could set it like all this. That's how you get each individual thing. Oops. Oh gosh. That would work. Or you could use this style array syntax. So I'm making the start and the end if I put it in this order. And what are start and end but points? So I could be like 2, 3, comma 2, 3, some braces inside of braces. That would also work. Those are 2 different ways to initialize it. Is that what you're asking about? Yeah. That would be how you do it with this particular definition. That is. We still good with that? Does that make enough sense? So yeah. Make structs. Use them inside of other structs. That makes your life easier. Makes you able to think about things at a higher level, I think. Okay? Let's keep on going then. So I think we're now ready for the main event. Let's talk about classes, because they're stuff built on top of structs. Okay? Classes form the foundation for this thing called object-oriented programming, which is very, very popular. Probably never going to go away. So let's get into that. Classes. It's a weird little word. We have so many meanings for this word already, right? But it's a new word. Classes in computer science are a way to package together data. This is what structs are doing. Structs are packaging together a bunch of data. So this is just like structs. So it takes the pieces from structs, just like structs, holds data. Every object holds data, plus operations on that data. That combination is so nice and powerful, okay? The operations become part of the type itself. Which is really weird to think about. But it shouldn't be, because you've been using this already. With strings, with vectors. You've been using classes all this time. So here are some silly examples of real-life objects that do things, because that's all that object-oriented programming is about. It's about taking like your programs and writing them as if they were real life things that you could touch, like they had buttons that you could press or something like that. So here are some examples of real life objects that do things, that hold stuff, right? What are the operations that you can do to those things, and what is the data that they should all hold, right? So for example, we could make a PowerPoint PowerPoint type that could hold this entire, all these lecture slides, right? So we could call it lec14 or something for today, and you could say lec14, and you can run an operation on it. It could be like lec14 dot add slide, and give it a name or something. That's an operation on lecture 14, a dot operator, right? Lecture 14's add slide. Add a new slide, please, to lecture 14, that object of the PowerPoint type. So in addition to holding the data that is like a vector of slides or something, got a bunch of fields, got a bunch of member variables, classes add operations as well. So like there's an add slide operation inside of the PowerPoint lecture 14 object. Maybe there's a dot save operation inside. Maybe there's a dot, I don't know, duplicate slide operation, dot bold kind of thing. But that's what classes are all about. You have the data that you're holding on to, just like you were with the struct, but then you're also packaging together that data with the operations that you can perform on it. So it looks a little bit like a function call, but not quite. It's like, please operate on lecture 14, that object, okay? You can make a cat type if you want to. You can make one for my cat. So you can make a cat class, and I don't know, maybe cats need, if you want to represent them in a program, they need a name, store that, and then an age member variable too. And then the operations that you could have on your cat objects could be like dot birthday, which will increment the age, dot eat, which will make him larger. Maybe there's a size variable. And then, of course, there should be a dot meow, right? That kind of operation. Those are the things that a cat can do, right? You can, of course, add more. But the whole point of object-oriented programming is that you're modeling your program as like a real-life thing that you can touch, okay? That can respond to your messages, your operations that you ask it to perform, okay? So dog D might have a woof operation, d.woof, okay? Does that make enough sense? You've been doing this. Strings are classes. Vectors are classes. You've been doing .at, right? You've been doing .size. You've been doing all that already. We can now make our own things that act like that. Okay? So let's add to what we've been doing. Let's change our point struct into a point class. All right? Let's think about some things that we might want to do with points. So, first of all, instead of struct, I'm going to say class here. All right? And then I have to say public colon, and I'll talk about that next time, why that's necessary. But you have to add that with classes. Still, you need the closing brace semicolon. But forget about these right now. You can then add your fields as usual. Add your member variables. Every point has an X and a Y. So just change struct to class. You can add your fields. Usually you should say public first. We'll talk about the differences. But yeah, now we can add extra things on top of that. We want our points not just hold our data, not just X and Y, but also have operations that we can perform on them. We want them to be able to respond to our commands or respond to our messages. Okay? So let's have negate. Let's have add. Let's make it run like this. Let's be able to negate a point in place by saying not negate point P, but let's just ask P to negate itself. Let's send it a message. Let's say P.negate. Isn't that cool? You could run it like that. And this is how you would declare it inside of the class. It's like, I have an operation on me, use the dot, and it takes no extra parameters. It's called negated. So this creates that operation. Put it inside of the class. That's where your operations go. Okay? And then add. Let's tell a point P to add itself with another point Q. So it has itself implicitly. It just needs one extra point now. Give me some other point, and then I'll give you back a new final point that is the sum of those two. Okay, so that the return type still point, of course. And I think, gosh, should we change this to void? Yeah, I'll change this to void. So then we could also, let's make a new operation that we haven't done yet. Let's make a scaling operation. So that scales a point by a certain factor, the double, some factor c, some constant. So let's say this is my p. P holds an x and a y, as usual, in addition to those operations. So let's say that p holds 1 and 2 right now for x and y. This is what I want scale to do. P.scale by a factor of 2, let's say. That will multiply the x and the y by 2. So now x becomes 2 instead of 1. Y becomes 4 instead of 2. So it scales it by 2. And that's another operation. It's called scale. It takes one extra parameter, and it just modifies the object, so it doesn't have to give anything back. Does this syntax make sense? It should be very familiar, right? It's just things that we can make ourselves now. Are we still okay? All right. Let me go to my notes, make sure that I'm doing all the right things. Yep. Looks good to me. So, yeah, let's go there eventually. I need to, gosh, I want to build that right now. Yeah, so let's do it on the next slide, actually. Okay, so I need more terminology now, of course, since I'm teaching you another new thing. So let's talk about that terminology before we go to code again. So now it's, instead of struct versus object, it's class versus object. We have things called methods. Members, we have a new type of member. And then object-oriented programming is a fancy term that I've been throwing out. Let's define that too. So, okay. A class is very similar to a struct. It creates another type, okay? But in addition to holding things, it also holds operations on that type, okay? So again, you have the concept of points. Like, we're going to make a point class now instead of a point struct. Point is the name of the class, and P is the name of the object. You can have many objects of type point, right? P is just one of them. You can make a point Q if you want. That would be another object. But point is the template, right? It shows you what you can have inside of every object of the point class. Okay? So the class is the name of the type, and object is a value of some class's type. And fields and member variables, those are all the same as for structs. Like, P will have an X field or an X member variable. P will have a Y field or a Y member variable. Those are all the same. But now we have operations as well. We have these guys. These operations are called either methods, like negate is a method, add is a method, scale is a method. They're also called member functions. So you have two names again. So these are also, this is negate member function, the add member function, the scale member function. Those are synonyms, member function and method. Okay? Those are the operations that you're giving to the class. Those are the things that points know how to do to themselves, in a sense. Okay? Those are the messages that a point knows how to respond to. That's another way of looking at it. Okay? And finally, OOP, which is short for object-oriented programming, is just this idea of packaging together your data and your operations, making a bunch of classes and using those instead of just a bunch of variables like we've been using, right? As much as possible. If you do that, you're technically using object-oriented programming. You're thinking about things in terms of objects and the operations on those objects and the data that they hold. Okay? So that is a lot of new terms. They might be a bit fuzzy at the start, but I'll be throwing them out to you very, very often from now on, so you'll get used to them. Are there any questions about this before I go to code? Because we're ready. We're ready to make our point class now. Let's do it. So just say, instead of struct, say class, and then add a public colon before everything at the very start. It's like it marks everything as visible to the user. So I'll define this in full next time, but what public means, just in case you're really wondering, is it gives the user of your class, gives the user access to everything below it. That's not enough room to write everything, sorry. To everything below it. So all these are now visible to the user, kind of. Okay? And then we're going to put our member variables inside as usual. And then we're also going to make our methods. You can give the implementations. Up here on this slide, I just gave declarations. You can give the implementations up here if you want in the declaration of the class. That's totally fine. It's not the normal way to do it, but it's good to get you started. So we're going to implement these here as well. Okay. And so now, if I do this properly, and I will in a second, you'll be able to make a bunch of point objects like this, P and Q. You'll be able to set their fields, X of P, Y of P, set those to 1 and 2, just like you would with the struct. And then you can ask it to do things. You can call its methods that you've made, like the negate method. You can say p.negate. That calls the negate method on P. It's specific to P. It's not like q.negate, it's p.negate. It's asking P to negate itself, not some other point. Right? That's the idea. So, yeah. Running all these in full should do this. It should make P and Q, right? Which always have X's and Y's. Those are their fields. Those are their member variables. So P and Q for that first line, that declaration line, should look like this. X and Y. They should be set to who knows what, question marks right now, because they're uninitialized. But then I go in and I initialize P's X and P's Y. So X becomes 1, Y becomes 2 here. And then if I call P.negate, that'll call negate on P. That'll ask P to negate itself. That'll make it -1. That'll make it -2. Okay? Does nothing to Q. If I wanted to negate Q's fields, then I would have to ask Q to negate itself. I have to say Q.negate. Okay, so there's a concept of this method getting the current object that you're calling it on. Okay? Even though you're implementing it in only one place. That'll make more sense as you do it. Okay? But let's go to the code now. So I'm going to take all this code and let's change it from structs to classes. Okay? Classes.cd. So instead of struct point, it's going to be class point. Alright? And I have to say public here for a reason. And then I'll put all my stuff. Double X, double Y. And then I'll put all these things as well. These are my methods. Boop. And I'll implement them. Okay, and let me go down here and use them as well. I'll delete the add, I'll delete the negate point. So I'll still have point P, I'll have point Q, print out P and Q, not a big deal. But P plus Q, I've made this a method now. I made add a method on point object. So I can say some point dot add with another point, and it'll add the two together, like I said up here. So let's use it like that. So P plus Q, I can either say Q.add P or P.add Q. I'll do it like that. Then instead of negate point P, I'll say P.negate. That's the method that I'm making. And then, I don't know, I'll scale Q. Q.scale by 2. Then I'll print out Q. So those are my operations. That's how I use them in this normal way, right? They're methods, so they belong to the class. They're defined up here. It's part of the class itself. Okay, it's not like a negate function. It's a negate method. I have to always say some point and then dot negate. It's part of the class. It's an operation only on points. Okay, so does the use make sense? Like this is how you would use add, this is how you would use negate, this is how you would use scale, given that they were declared / defined up here. They look like functions, but they're not. Because they're inside the class, they are methods. Okay? Are you ready for the implementation? So this is where it gets a little interesting. So in negate, for example, in here, because I'm a method, I know that somebody called me like this. Somebody said p.negate. Somebody said p.negate or q.negate. Somebody gave me themselves as a point, right? I'm inside the point class. So I have access to an x and a y, okay? Because I am being called on a point object. In here, I can talk about x and y, and they are the x and y that belong to the current object that negate has been called on. Okay, so for example, when I call p.negate, it jumps up here, and the x and the y that it knows about, if I just mention them, it's p's x, it's p's y. That's something to get used to. So I don't have to redeclare anything, like they're these fields. I can access them. I can say, my x, whoever is being called right now, whoever's having negate called on them, change their x to be its negative. Change their y to be the negative form of it. Does that make sense? This is special. It's a method. I'm calling p.negate, and so I have access to my fields because I have been called on myself. I know that I am a point. I have an x and a y. You can just talk about them. They exist. They're part of you. And that will correctly negate the point, whichever one that it has been called on. If I said q.negate, I'd be jumping up to here, and it would be q's x and q's y that I'm referencing when I'm talking about x and y. But I'm calling it with p, and so this is p's x and p's y that's getting changed here. Okay? So there's a concept of your member variables and being able to access them inside of the method. All right? That's weird, but it works. Add can be the same as the last time I did it. Point results. I have to add results x. It needs to be my current object's x, because I'm going to call this on like this, p.addq. So the current object is p, then I'm adding it with some other point q. I'll take that by constant reference. Why not? X plus the others x. The results y needs to be my y, my current object's y, plus the other objects that I put in here, plus their y. Return result. Okay? Scale. It should be my x needs to be scaled by c. My y needs to be scaled by c. I can talk about these things. Oh, sorry, it should be void. Excuse me. I changed my mind. There. That's the idea. My x needs to be scaled, my y needs to be scaled. So these are the implementations. They will work. So, gosh, how do I want to show this to you? Here's the use of the negate down here. Or the add, the negate, the scale. And here's their implementation. Let's do negate and add first. So there's add. It's taking somebody else, like you're calling it with p. P.add, so p is the current object. If I say x up here, it's p's x, p's y. Then q is going to get set to o. And so I'm doing stuff based on that. And so I see, I think the very first time this is the sum, right? 6.5, 10.89. Because it's jumping up to here, it's running things, it's giving back that new point. And this is the sum of those. Okay? Same with negate. It's jumping up here, setting x to be p's x, setting y to be p's y, and I'm allowed to touch them. So it makes it -2, -3. And then finally for scale, it takes what q was, multiplies it all by 2. Multiplies its x by 2 and its y by 2. And now I have this answer. Okay? That's the idea. So are there any questions about what's going on here? I have one last diagram to draw for you, but anything that is extra confusing right now? So sorry I can't put the whole thing on one big slide, but here's the start of it. class point public, double x, double y, and then here are the methods.
So like the client O, the class point O, in main is x and y, but you don't have to like type O to make a connection or make this function call.
This is just a parameter, just as usual. It takes one thing. So here I'm passing along Q for O.
Oh, okay.
See that? It still needs that parameter.
Okay.
Yeah, it's just 1 instead of 2 now, because I used to have it be add P and Q together. But by using the dot, it's a method that belongs to P, in a sense. I only need to pass along the other object that I want to add into myself. There's always a concept of you. You are the current object that this method is being called on.
Gotcha.
Yeah, good question. So let me draw this diagram, and that might help things make a lot of sense. So, for example, inside of P.negate, the x is P's x, and the y is P's y. Here's kind of what's happening. So here's main. Main has P and Q. And it's eventually going to have P plus Q, right? P plus Q. Boop, boop. So let's say these all exist. P has an X and a Y. The X is, I don't know, was it 2 and 3? Yeah. Q has an X and a Y. Not that it really matters. 4.5, 7.89. And then I called P.negate. Okay? So here's kind of what's happening. I'm jumping up to the body of the negate method when I call P.negate. So I'm inside of the negate method. And then X, whenever I say it, everything in green belongs to the negate method. X for the negate method is P's X. Y for the negate method is set to P's Y. You're just able to access them like that. And so this will make it -2. This will make it -3. And you're touching P, just like that. Okay? Because you're asking P to negate itself. If you were saying Q.negate, then X would be set to Q's X. Y would be set to Q's Y. It would be like a reference in a sense. Very similar to reference passing. Okay? So, yeah. The key idea here is your current object's member variables. Current object. That is the key term. Your current object's member variables are the ones that are visible inside of a method. Okay? You get P's X when you call a method on P, like P.negate. Okay? And you talk about X. Because you're asking P to do stuff to itself. It's like, all right, I know about my X, not somebody else's. I'll manipulate my member variables. It's acting on itself, in a sense. Okay? I hope that helps it make a little bit more sense, but this is definitely a harder topic, and it's something that you would probably want to go back and study after class. Okay? So class point, double x, double y, all of our operations called methods or member functions, and here I am using them. Yeah. Any last questions about this stuff? So I believe that is where I wanted to stop today. Next time we'll get fancy. I'll show you how to do it right. So I was a bit lazy when I was implementing this today, but it still is working, still is correct. But we'll go a bit further next time. And then, yeah, we'll have a new lab assigned on Thursday, but before then I want to talk to you about this. So you know how you evaluated me in the class while like I was outside? I won't get to see those things that you wrote until after the semester is over. So I want to do something that I will be able to see just in case something needs to change about the class right now while you're still in it. Okay, so here we are in week 8. There are like 16 weeks of classes and 1 extra one for finals week. So we're like about in the middle of the semester, so you should pat yourself on the back. You've made it this far. And so I'm calling this the mid-semester anonymous feedback. So this is not for a grade. Please do this if you feel like doing it. I would appreciate it. But I've made a little anonymous Google form where you could fill things out about the class and I will be able to see them as soon as you submit them. I won't be able to see that you yourself submitted these things, but I will be able to see what you wrote before the end of the class, just in case there's something that should be fixed. Okay? So please give me your feedback. I would appreciate it. It would help me improve the class for this semester and then for future semesters. Okay, so fill this out with as much or as little as you would like. I would appreciate it. Okay? I think that is all that I have for you. Yep, and then the lab will be released next time. Any last questions about anything that we would like to get recorded? All right.